One of the more complex and challenging analysis modules in the Universal Translator is the one related to measurement and verification. Especially in the modern day of building improvements, a lot of the retrofits that we see are associated with saving energy, taking an existing building and making improvements that reduce overall energy use. And one of the big challenges has been quantifying the actual savings that occur because they depend on so many factors. And in particular, they depend on the measurement of the energy use before and after the retrofit. And those typically are dependent on the time during which those measurements are taken. So you might have a measurement taken in spring, a retrofit taking place during the summer, and then measurements taken again in winter to verify the new operation of the building. And obviously there are many complex engineering tasks associated with making sure that those measurements and their analysis are meaningful. So the Universal Translator has a very detailed measurement and verification analysis module that makes running an entire analysis like this possible in maybe an hour or so, something that used to take far longer. And it's very interactive, so it gives you a very good idea of how accurate those results are. Quite a fantastic module, actually. So let's start by looking at a typical problem, which is a building that has been retrofitted, and we have some data that shows power use before and after for the whole building. The data for this is in the folder that comes with the Universal Translator installer. So it doesn't install automatically in program files like some of the other examples did, but instead it comes as a zip file that you can download from the website. So in this particular case, this is the analysis module data for Quest listed here. So I'm just going to unzip this, extract it into the same folder, which creates a directory here. I'll open that. There's the measurement verification sample data, and it contains these three very small text files here. I'm going to take those, shift select them, drag them over into the UT. There we are. And as usual, let's start off by making some charts. I'm going to throw out the ones that exist in here already. Let's start by making some charts and examining what is actually in that model. So I'll open that new chart and simply drag the channels in here. So we have base case kW use. So I can see we've got, these are probably weeks, looks like. So we have power use data. This is about 700 kilowatt. Power use data before and after a retrofit. So here's that period we were talking about. Here's some data before a retrofit, then the actual construction takes place, then here's the data afterward. Normally speaking, what traditionally we have done in such cases is to look, for example, at the energy use of a building compared to outside air, for example, because it gives us some idea of how the building responds to weather. And for most buildings, that is meaningful. It may be that for some things like a data center, it's less meaningful because, of course, there the weather makes little difference to the amount of servers that are running and consuming energy. But for most buildings, that does make some sense. So in order to look at what the energy consumption is like, I can make a chart that's a scatter chart in which I plot the base case kW against the base case outside air temperature, which I have here. So there's outside air as the x-axis, energy use as the y-axis. And of course I get this sort of typical scatter of two clouds of data here, and often occupied and unoccupied. So first thing I would normally do is filter that. I can make a filter that just is used for occupancy scheduling. So I'm going to call this MV occupancy, for example. And at a guess, I'll just hazard a guess, I will say that my building will typically be occupied between 6 a.m. and 8 p.m. or something like that. To 8 p.m. Monday through Friday. Pretty standard. And then I will take the chart that I have here and filter it. So I'll take the Y data, show the advanced input selection, and use that schedule bin. That's taken out most of the nighttime data here, but not quite all. So I'll change it a little bit more. Actually, I'm going to rename that bin as well. I'm going to call this occupied, which if you look at the video for filters automatically means that the default bin now contains everything else. So the default bin contains the unoccupied periods. So that didn't quite get rid of all these lower values. So maybe I'll make it 7 a.m. to 7 p.m. Let's see how that works. There's less, maybe a little bit more even. How about 8 a.m. to 6 p.m.? Okay, so that's gotten rid of pretty much all the unoccupied hours. So there is the energy signature, if we like, of the building before the retrofit. Now, if I wanted to compare what happens after the retrofit, as is usually the question, how much did we save? What can I say? I can, of course, take a look at the post-KW data, but unfortunately, I can't drag it into here to overlay. So simply do nothing, because, of course, the time scales are completely different. The weather data that I'm using here to compare against is different in the pre-period and in the post-period. So if I wanted to do that, I would take this post energy data back out and create another scatter chart that has a different scale in terms of time for the post data. And I can look at the post outside air temperature data, compare that to the post KW data, get the same kind of scatter chart, and I'll apply the same filter for this, assuming that the retrofit didn't change the occupancy hours of my job. So I'm going to assign that same thing, occupied hours. So the best I could do is to kind of look and say, okay, on average here it's sort of 70 degrees. I was around the 700 kilowatt mark, whereas now at 70 degrees I'm more like 600 kW. So clearly the building is more efficient. For the same outside air temperatures, I'm consuming less energy. But making sense of this in a more consistent manner typically required a lot of spreadsheets. This is where the M&V analysis comes in, and it allows us to make a standardized approach to this kind of problem much more simple. So the next video is going to show M&V analysis module, which allows us to overlay pre and post data, automatically correlate it to outside air weather data, and also use different multiple schedules and filters.